Hello, everyone, and welcome back to more statistics, where today I will be talking about negative binomials and zero-inflated negative binomials. I'll briefly be explaining some theory behind these models as well as running some examples. So let's start with a negative binomial, which is a type of regression model to model count data. And we use this only when the variance of the data are higher compared to the mean, and this is what's often referred to as over dispersion. So let's visualize this and go ahead and set our working directory first. And then we want to read in what I've called the B-longum data frame. If we go ahead and open this up for our example today, our dependent variable is Bifidobacterium longum, which is count data, and then we have our independent variables, duration of breastfeeding, and delivery mode. Delivery mode being categorical and having two levels, vaginal and cesarean. Alright, so let's go back to our R script and plot this data. If you don't have the ggplot2 package already installed, you can go ahead and use this code right here, and then load your ggplot2 package. So let's go ahead and use the histogram function. And before I make any stylistic changes, I want to show you how this looks like. This is how a histogram plot generally looks like with the ggplot2 package, but we can make stylistic changes to this. For example, I can specify that I want my border color to be white, and I can fill in the bars with a specific color of my choosing. So you can already see some changes here. Now, I'm personally not a huge fan of the checkered layout, so I'm going to apply the classic theme, which can make the background more of the white color. Of course, when we get the code right, it's always the one thing that's missing, and it was the plus sign in our case. So this is how the final output looks like. All right, so we can also confirm this another way by looking at summary statistics. So we can see here that the variance is much higher than the mean, which confirms what we saw visually as well. Now I will say that these data here are completely made up. I used a random number generator, so they don't necessarily mean much beyond just the numbers that we're using for our example today. So now we can proceed with running our model, and in R we can use the glm.nb function from the mass package. I already have this installed as well, but if not, you can do so using the following commands and then load it in. And you will get this warning message. It's always a little bit scary when it's in red, but it doesn't mean you did anything wrong necessarily. All right, so let me call in a new data frame, model 1, and I'm using the glm.nb function. Now this tilde here means a function of, so in our case, b longum being a function of its predictor variable duration of breastfeeding. And we can look at the summary output. Now, what's of interest to us here is our coefficients. We can see these variables are significant and the direction of the coefficients. For categorical variables, the default reference category is the level that is not included in the table in the output. So if we were looking at delivery mode, which we will look at in the next example, you'll be able to see what's specified in the output model, the certain level that is specified here. Now, the residual deviance shows how well the response is predicted by the model when the predictors are included. The lower the value, the better the model is able to predict the value of the response variable. And for a well-fitting model, the residual deviance should be close to the degrees of freedom. Next, the model also gives us the AIC, or the IKK information criterion, and what this is an estimator of the prediction error and therefore the relative quality of our statistical model for our data. In other words, it provides a mean of the model quality, so it can help us to choose the best model based on predictor variables that we can add or remove. So in yet other words, the lower the AIC, the better. So let's put this to the test by changing our combination of predictors and adding delivery mode to our model. This is model 2. Again, I'm using the glm.nb function. And another way to do this, actually, you see here that I was specifying the data frame every time I was referring to our variable name. But an easier way to do this may be to simply specify the data frame at the end, and I'll show you this in a second. So we'll keep duration of breastfeeding within the model, but we will also add delivery modes. And then this is where we can specify the data frame that we are using. And in this case, it's B longum, this one right here. All right, and again, let's look at our summary statistics. Okay, so here you see what I was referring to in terms of categorical variables being a part of the model, and the reference category again being the level that is not listed in the model. So these coefficients right here refer to the level of vaginal delivery in reference to the cesarean group. the cesarean delivery group. Okay. Now, we can also have delivery mode as its own predictor. So let's go ahead and create our third model. Bifidobacterium longum as a function of delivery mode. And again, you have to specify your data here. Now, comparing these models, we've got an AIC of 4849 for Model 3, 4851.6 for Model 2, and about 5007 for Model 1. And so we can see that Model 3 has the lowest AIC. All right, so now let's go back here to our histogram. If there is an over-dispersion of zeros, so where the peak of the curve is highest at 0, then we should use a zero-inflated negative binomial model. What a zero-inflated model does is take into account excess zeros in your data. There are two kinds of zeros that are thought to exist: true zeros and excess zeros. And with that in mind, zero-inflated models estimate two equations simultaneously, one for the count model and one for the excess zeros, and then it combines them. So first, a logit model is generated for the excess zero cases, predicting whether or not a participant would be in this group. And then a negative binomial model is generated, predicting the counts for those participants who are not excess zeros. And finally, the two models are combined. Let's take a realistic example here. So if my dependent variable is how many hours of sleep I got as an undergraduate student during midterm season, then there were probably a lot of days with 0 hours of sleep in there. Good times. So here, while 0 is the most common frequency of B longum, it is difficult to see from this histogram alone if the number of zeros is in excess of what we would expect from a negative binomial model. So we can run a zero-inflated negative binomial model and test whether it better predicts our response variable than a standard negative binomial model. So to run the zero-inflated negative binomial in R, you want to install the pscl package and use the Zero-infl function as follows. Again, I've already got this package. I've got them all. So I'll go ahead and load it. Again, with the red alert message over here. All right, so let's go ahead and put this into a zero-inflated negative binomial. So this is our function, and then we've got our dependent variable as a function of, let's do delivery mode here. You can specify that this is a logit link. Using a negative binomial, this could be a Poisson, it could be something else, and then our data frame B-longum. And let's go ahead and run this and call out our summaries. Okay. So let's look at this for a second. We can see the residual values and two subsequent coefficients. So the count model here represents if you had B-longum, here's how many you have. And if you delivered vaginally, you're likely to see fewer B-longum because of the negative coefficient. Now, the zero-inflated model coefficients are a bit different, and you can think of this as the logistic part of the zero-inflated model. So this is describing more, did you have 0 B-longum or not? So do you have 0 B-longum or 100, 200, 300 or more? Okay, so now that we've run both the negative binomial model and the zero-inflated negative binomial model, let's go ahead and compare the two AIC values for these two different models with only delivery mode as the predictor. So this gives us the degree of freedom and the AIC value. And so the degree of freedom for our negative binomial model is lower than our degrees of freedom for the zero-inflated model. And what we can see from the AIC values, these are quite similar, but typically you would consider a difference of 2 units to be important. And so in this case, our lower AIC with the negative binomial model may be our better model, and we may favor this model for our analysis. So this was a very brief summary of how we may fit a negative binomial and the zero-inflated negative binomial model using a made-up data on the Bifidobacterium longum species within the microbiome. I hope this was helpful, and if you have any questions, as always, please feel free to leave them down below, and I will see you in the next video for even more statistics.